This is a presentation on waste and plastics for Year 9 Geography at Hillbrook Anglican School. In one of our previous lessons, we've talked about the Great Pacific Garbage Patch, the giant gyres or whirlpools where there's plastic accumulating in vast quantities. Now as we go through this presentation, you'll see that plastics are one of basically the miracle products of the 20th century and continuing into the 21st. You can see this consumer ad here advertises the pleasures of plastic wrap. You can see that plastics are also being used for huge other quantities of goods. For example, the vaguely popular iPhone 5C. This one here is a molded plastic, and famously Lego blocks. All these things and tens of billions of other products are all made from plastic. Plastic in itself is derived from oil. From the oil is drawn a series of things called monomers, which are then developed into a more complex object called a polymer. This is called polymerization, and polymers can be formed into just a huge quantity of different shapes, and it's these different shapes that allow us to have plastics of all different types. One of the big things about plastic is it's a completely inert substance, right? So that's the spelling of inert. That's why you can use plastic for carry things like hydrochloric acid. So key things to remember, these are the absolutely important stuff, is it's inert, it's non-reactive, and as a consequence of the fact that it doesn't react with other products in nature, it means it doesn't decay. Now, it used to be, since ancient times, people had used glass for storage. So all of these here are examples of ancient forms of glass. Now, the big thing with glass is it's very brittle. It doesn't cause any damage to the environment. It's reasonably easy to make, but it's very brittle. So it's not that easy to form into infinite shape. Pottery was the other big storage item that used to be used in the ancient past. Now pottery is just derived from soil. When it gets powdered up, it returns to the soil. It's pretty brittle again, but fairly durable and fairly cheap to make, but it didn't certainly give a great deal of options. One of the other things that we've got here is rubber, and you can see there that rubber dripping naturally out of a tree. One of the big things that they found about rubber, though, is whilst it could be shaped into some sort of storage items, it tended to remain sticky, and if it didn't remain sticky and it dried out, then it ended up becoming quite brittle as well and not particularly flexible. So rubber, glass and plastic have all been used as containers for things throughout time, none of them causing big environmental damage, but they certainly had big limitations. Until this guy turned up and started the whole ball rolling. This guy is called Charles Goodyear. And you probably heard his name before. Is particularly famous because he still gives his name to a fairly major tyre company, Goodyear Tyres. What Goodyear realised is that he could take natural rubber, which is shown here in giant blocks. He could mix it with sulphur. What he would achieve was what's called vulcanised rubber. So vulcanised rubber was used to make the first pneumatic tyres. Pneumatic meant that finally they could have tyres that could actually absorb shock. Now these ones here you can see are pretty much ones from a cart, but they've got a pneumatic tyre on the outside. This gave them a fair bit of flexibility, and suddenly this started a whole new industry. So people started to wonder, well, if he's achieved this with rubber, he's created a type of rubber that's flexible and will snap back into place, then, well, what else could be made? But for a fair while, nothing happened. Okay, but they did find plenty of uses for rubber. Okay, for example, in this ad, they're talking about vulcanized rubber soles. So the original Dunlop Volley shoes used to have vulcanized rubber on its sole. The next plastic that came along was a type that was called celluloid. Now, this is not science, so I'm not going to bore you with all of the scientific details, but celluloid was another type of polymer. And one of the most famous things that it was used for is shown here, which is film cartridge. But what celluloid could also be used for was to make a sort of fairly brittle sort of plastic, but that could be molded into a huge range of different shapes. It could also be used to make the appearance of very valuable things. So for example, that one there is meant to look like mother of pearl. These ones here are meant to look like ivory. This here is meant to look like engraved timber. So celluloid was able to be used for a whole lot of different stuff. The next big one, which you might have seen, is a really famous type of plastic, and the first real plastic called Bakelite. Bakelite was able to be molded, and that meant that it could be pushed into virtually infinite numbers of shapes. Bakelite was used for everything from telephones to radios, to jewellery, to decoration around the home, and it was seen as absolutely groundbreaking. It was the first true plastic. Another big one appeared during the World Wars, where they messing around with different types of polymers and ended up creating something which was initially used to replace silk. And this was called nylon. Nylon most commonly now gets used for rope and huge numbers of other things. It's an incredibly long-lasting polymer. If you haven't had a chance up until now, it's probably a good idea to try to find this particular thing online. It's a history of all of the different types of plastics, when they were made and what they were used for. It's a really useful one. One of the big things is that now we can actually create something which is called a bioplastic. That is, bio from life, so it's a life plastic. Okay, so for example, like these dog poo bags, which I certainly know that I buy, this means they're 100% biodegradable, means they're able to break down in nature and disappear completely. Now, one should notice the difference. Biodegradable and degradable are different. Degradable just breaks down into smaller pieces of plastic. Biodegradable completely composts and disappears. Basically, bioplastics can be brought from a huge range of different things. So for example, there's natural cellulose, there's starches, bacterial polyesters, soy protein, vegetable oil, and triglycerides. All of these give us what are called bioplastics. Now this flowchart here is a really nice one, which shows the different processes involved in bioplastics. And I'd like you to have a bit of a read through in a moment. I'll give you a few minutes to have a look. But one of the things to really note is that a lot of these come from foodstuffs. And if you remember, when we looked at the stuff on food, it was looking at the fact that using stuff that is used for food to create non-food related products is often a bit controversial. So pause this one, have a look at it, have a read through. But yeah, this is stuff about the life cycle of bioplastics, which in theory can go straight back into compost and then be used as the raw material for growing new stuff. One of the big things is that we're not actually saying that plastics are an evil thing. Plastics are actually incredibly versatile, and as you can see here, most types of plastics, which are categorized in this infographic, most types can be really easily recycled. So that in itself, you look at it and go, well, aren't plastics really good? Well, one of the problems is that plastics, remember, are derived from oil, and oil is definitely running out. At what rate? A lot of people disagree, but oil is running out, so it's not a renewable resource, and therefore plastics in themselves are not completely sustainable. Also, one of the things to keep in mind is that whilst plastics can be recycled, this is sort of showing the process that's involved in that. Now, it all looks very nice and green, and they've got it done in things to keep in mind is that all of these things involve the use of energy. Every time you're using energy, you are creating waste of a type. And if you remember our thing about the waste management hierarchy, avoiding and minimizing or reusing is the considered the best option. So we're in the third best option with all of these, recycling. Now, bioplastics, obviously, you're starting to get up into the ability to reuse them, but even they are involving a level of recycle. So it doesn't solve the problem of the fact that we're still creating too much stuff, but certainly bioplastics might give a better option. When it comes down to it, this is our big problem here. The big problem is, if you have a look, white column is sales that involve PET plastic bottles. Now, this is just one type of bottle, but nonetheless, it gives you an indication of this sort of waste that we're going through. The black bar is always the waste bar, and look how much of it gets wasted. Only a small proportion of all of our PET plastic bottles gets recycled. So they're easy to recycle, it's just that people don't do it. And if you remember the stuff from landfill, this is our big problem. So we have got things like, for example, here, this disposable diaper, 450 years that will take. A plastic film container will take 20 to 30 years. Monofilament fishing line, a type of plastic, 600 years. A rubber boot sole, vulcanized rubber, 50 to 80 years. A foam plastic cup, 50 years. Plastic bag, 10 to 20 years. Right, so all of these things, all of this waste is a problem. Okay, but the fact that we've got so much plastic that gets into the atmosphere that doesn't get recycled is massive. Now, this glass bottle would, you could say, well, that's going to take 1 million years. But the thing is, the glass is made out of sand, basically. Sand is something that's fairly easy to come by. This is less of a problem than plastic, especially stuff like monofilament fishing line, which just breaks down into tiny, tiny little bits of plastic in the atmosphere. I hope that's been helpful and informative, and helps you to continue with your understanding of plastics.